Hello guys, my name is Ali.
And my name is Mohit.
Today we are going to talk about FM radios and their working.
Many of you would have wondered that how is it that the radio receives signal and is able to differentiate between the ever increasing radio stations.
For explaining that, we have to understand the working of a radio receiver. This is a block diagram of a typical radio receiver. As you can see that there are many components in a radio receiver, but don't fret, we will be talking about each of them one by one.
The radio receiver receives signal from the surroundings using its aerial. As radio waves traveling through free space reach the receiver's antenna, they set up or induce a weak electric current within the antenna. The current pushes the oscillating energy of the radio waves along the antenna, which is connected to the radio receiver by a transmission line.
Having successfully received the signal from the antenna, we move to a RF filter. Radio frequency represents a class of electronic filter designed to operate on signals in the megahertz to gigahertz frequency ranges. Basically, what an electronic filter does is, it removes the unwanted frequencies from an electrical signal. Thus, we are filtering out the noise and keeping the part that is required by us. The simplest RF filters are made using L, C and R elements. Here, we have got a very simple RF filter making use of a resistance and a capacitance. As we know that the reactance of the capacitance is dependent on the frequency of the AC source, using the formula Xc equals to 1 upon j omega c, we can see that as the frequency increases, the reactance decreases. So, on very high frequencies, the capacitor becomes almost conducting. So, as a very high frequency signal passes through the RF filter, the capacitor is conducting and hence the V output is 0 in that case. So, what we are doing is, we are filtering out the high frequencies in this case. This is how a very simple RF filter works.
Moving on, the filtered signal goes in an amplifier. A radio frequency power amplifier, RF power amplifier, is a type of electronic amplifier that converts a low power radio frequency signal into a higher power signal. Modern RF power amplifiers use solid state devices such as bipolar junction transistors and MOSFETs.
Now we have a roughly filtered and amplified signal. Now we pass the signal into a mixer. In electronics, what a mixer does is, it creates a local oscillator frequency and merges it with the incoming signal. In its most common application, two signals at frequencies f1 and f2 are applied to a mixer, and it produces new signals at the sum f1 plus f2 and difference f1 minus f2. The difference f1 minus f2 is called intermediate frequency and is used in all processes from now onwards. The mixer has a very important role in changing between various radio stations, as we will explain later. The intermediate frequency is useful because of these reasons. The circuit performs poorly on high frequency, therefore as IF is considerably lower than original frequency, this problem is resolved. Another reason is that as the radio receiver can be tuned to various frequencies, using IF, it is possible to get a common frequency to work upon.
After mixing, we take the IF signal to a filter where it is filtered, thereby removing any unwanted frequencies. Consequently, it is amplified.
The amplified IF signal is then transferred to a phase detector. A phase detector or phase comparator is a frequency mixer, analog multiplier or logic circuit that generates a voltage signal which represents the difference in phase between two signal inputs. It has one input from a voltage oscillator and returns output proportional to the phase difference of the signals. The error is fed back to the voltage oscillator and it then generates the appropriate input to be fed in the detector.
The output signal is then passed through a low pass filter, and there you have it. What we receive is the audio output of the information carried by the signal. However, one question remains: how do we switch between various radio stations?
Using a tuner. Typical radios are manually tuned by the operator by twisting a knob or dial, which varies the tuning of the variable capacitor. But wait, first we will talk about the circuit in detail. The most important part of the circuit is the input stage, where positive feedback is used to achieve good sensitivity and selectivity. The first stage is adjusted so that it is not quite at the point of oscillation. This increases the gain and the selectivity, giving a narrow bandwidth. To achieve this, the potentiometer connected to the drain of the FET must be adjusted very carefully. Optimal performance of the receiver depends on its setting. In ideal conditions, several strong stations should be obtainable during the day using a 50 cm antenna. This ranges cover the 49 meter and 41 meter shortwave bands in many European stations broadcast. The first stage is a selective amplifier followed by a transistor detector. Two low frequency amplifier stages completes the circuit.
Now we will discuss how to tune to a particular radio station.
In order to tune the receiver to a particular station, the frequency of the local oscillator is controlled by the tuning knob. For instance, tuning of the local oscillator and the RF stage may use a variable capacitor or a varicap diode. The tuning of one or more tuned circuits in the RF stage must track the tuning of the local oscillator. Now you can tune into 93.5 FM and enjoy your favorite songs.
Wow, that was quite a handful. Goodbye guys, thanks for watching. Do like this video and subscribe to our channel.